Hello and welcome back to the Oxford MAT Livestream, coming to you unusually on a Friday because I wasn't available yesterday, but here we are. I think it's going to be a quiet one because it's not the normal day of the week for us to be doing this, but let's see if anybody's here in chat. I think we're live on YouTube and using slido.com/matlive, just like normal. So if you're over there, then let us know. Otherwise, just me. I think I can record 2 hours of talking about maths just on my own, but let's find out if anybody's been able to tune in on Friday. So far, no. Anyway, right, okay. Test booking is currently open. Stress on the word currently, or now, literally now, at the time we're live. I believe it's open until 6 PM UK time. So if you're watching the live stream live, and you haven't booked a slot to take the test, and you're planning to take the test in 2025, then please stop watching the video, go and book a slot to do the math. I hope that doesn't apply to anyone. I have got some emails from people since last week saying they missed the booking deadline. I hope that's not anyone who's watching these videos over there. But hello, people are joining chat. I have to press this button, don't I? Hello to turn on messages. There we go. Hello to Jacob and Anonymous and Adam. And I see another anonymous person, Ruben, and Ruben possibly open day, all very excited. And Evie is here. The different thing was cancelled. Oh, there we go. So I've got a question. They say, do you live at the Oxford colleges? No, I don't. I teach at one of the Oxford colleges, but a bit like your teachers at school, I suppose. Probably they don't live at the school. Or maybe they do. Who knows? I have to go and live somewhere else. I think some of the tutors I think live in college, but not all of them. Lots of them have got sort of normal accommodation outside. Anyway, never mind. Not me. Right, hello Mary, hello. More anonymous people. Good reminder that you can be anonymous. I'm having quite a good day. Let's find out if they're having a good day. On this 5-star rating scale thing. So they can vote in chats to let me know how their day is going. You can also message in chat to let us know how your day is going, of course, if you like. Good to have you with us. The plan is, like normal, to look at some maths questions. I've got 2013, 14 and 15 today, and we will do some voting. I think there's enough people here to do some voting, but the ones I've put in the thumbnail are things like this, with 3 logarithms in. So I'll just have that on screen for something to have on screen. Someone says, how do I know if my maths application was synced with my UCAS application? I don't think you know. But I think you know what your UCAS ID is. So if you've put your UCAS ID in, like your UCAS number, then my assumption is that it's going to be fine. I don't know if the screen shows you a way to check, but I imagine that we're going to contact people. If we can't match your application to your MAT registration, I imagine we're going to contact you to find out what's going on, because we're expecting everyone to take it. We can't do that yet because we haven't got all the applications yet, but I imagine that at some point, if anything's going wrong, we will be contacting people. We have contact information through UCAS applications. That's what we've done in previous years. I imagine that's what the team is going to do this year as well. But in some sense, there are hundreds and maybe thousands of people doing this. So there's maybe not an active way that you can. Please don't email us to check that things are fine if things are probably fine. Good, right, okay. People are having quite a good day, except for, I think that is, due to low numbers on Friday, I think that might be one person, bless them, who's having a terrible day. And I see them. They're having a terrible day, and they've turned up anyway to do some maths. Possibly the maths will make their day better. They haven't left room for it to make the day worse, so let's hope, I suppose. Evie says this paper was taken on their birthday. It's quite tempting to go and find out what Evie's birthday is, but I think I should keep looking at what should I look at? I should look at the math question, shouldn't I? There we go. Right, that's switched on. That's switched on. That's switched on. Should we just do this math question? We'll do some voting in a second, but let's have a go at this math question, right? We've got these 3 facts about the 3 numbers, and we are not asked to solve them, which is a bit unusual. Normally when you've got 3 equations and 3 unknowns, you just go and solve them. And in fact, maybe we should do that. Well, maybe we should try. The options here are a bit strange. Now, I think that you might expect them to say what are the values of A, B and C, but perhaps because it's multiple choice, that would make it too easy, because you could check the numbers. Maybe it's the case that there's multiple solutions, in which case they would have to spell that out in the option. It'd still be easy, you would check both. But to make the question more interesting, I think they've phrased it like this, to say, essentially, can you solve these equations? With the possibility here that you might not be able to solve them. If they're contradictory. You've seen contradictory equations, right? If you're trying to solve x equals x plus y and y equals 3, then these are contradictory because they don't work together. That's a pair of simultaneous equations that involve x and y and some numbers, but if you try and solve them, then you don't get any, there's no pair of real numbers that work. The second one tells you that y has to be 3, and then the first one says, uh-oh, x has to be 3 more than x. There aren't any real numbers that are 3 more than themselves. So they could be contradictory like this, or they could be satisfied by infinitely many values. You've seen things like that as well, haven't you? So if one of the equations says that x is 2y, and the other equation says that y is x over 2, well, there are infinitely many numbers x that work in both of these equations simultaneously, even though there are two equations. They sort of contain the same information in some sense. So for any value of x, in fact, you can find a value of y that works here, and then it also works in the second equation. So you've seen both of these things happen down here, and then you could definitely imagine things being satisfied by two values of a, can't you? So if it turns out to be something like that, then there might be two values of a. Oh, I've just realised that I've been told that they're positive. I've been told they're positive. If you see something like that, then you might think, aha, this has two values of a. Some sort of quadratic. Right, okay. Let's not do the countdown. Evie's helpfully told me when their birthday is without me having to scroll over. 6th of Thursday? I'll try and remember and say happy birthday, but let's find out if it's a Thursday. Does New College does have a link with Wales? Yes, that's not quite off topic, is it? I suppose it's off topic from this logarithm business. But yeah, New College has a link with Wales. We have lots of school visits from schools in Wales, and Seren are pretty big in Wales, I think. Yeah, right, good. Okay. Why do people with 95 plus on that still reject it? If you mean after interview, then it's probably due to the interview. And then they say, do they bomb the interviews? I'd never say bomb the interviews. Just we have a lot of strong candidates, right? So you don't have to take people just based on that. Right? We also have interviews. It would probably be less confusing if you sat in all of the interviews, but nobody sits in all of the interviews. So what am I talking about? Anyway, should we solve these questions involving logarithms? I think we probably should. Because they're positive numbers, I think it's okay for us to say that a is b squared. When I read this question, I'm a tiny bit worried about the case where b equals 1, because log base 1 is quite weird. It doesn't really work. Often when you meet logarithms, they tell you not to put 1 in the base down here, right? Because if you meet questions like the value of x such that 1 to the power of x is equal to 3, that's not really a thing. It doesn't have any solutions. Not in the same way that 2 to the x equals 3. That one's happy. If the base is 2, that was quite nice. But the number 1 is quite special. It doesn't really behave well. So I'm kind of worried about... I'm a bit worried about a equals 1, and I'm a bit worried about b equals 1. I've seen an a down here as well. But I'm only a bit worried. I've made a note for myself, and possibly when I come back to check my solutions, I'll make sure that I haven't included any 1s down there. Yeah, just because I know that's weird. Anyway, other than that, I think I'm going to convert them all into equations like this. I mean, they were equations before. Now there are equations that don't involve logarithms, and I suppose that's the key bit. So I've got simultaneous equations. My plan now is solve. And they're not simultaneous linear equations, for which I'll try and substitute one into the other, but maybe chat's got a strategy. This is going to be a little bit hard to describe in chat, isn't it? But if I number the equations, maybe you can tell me which two. I've circled numbers, I can't do that in chat either, but equations 1, 2 and 3. Maybe you can tell me which pair of equations you would look at next. Which ones are speaking to you? Which ones feel like they should be combined together into some interesting result? You could take any pair of them and add them together, right? You have lots of choices here. Something I'd like you to be aware of really is just how many choices you have at different moments like this. where I think you can take any pair of these equations and say something, and it's sort of your choice. Maybe you did this question already and you haven't made a choice instinctively without thinking about it. That's cool. You should make a note of what it was though. Now that you've done the question, you should go back and look and see which choice did you subconsciously make. Was it the first two because they're on the left? Was it the outside two because they both involve A, and A is the first letter of the alphabet? I don't know. Which way around? What's your preference here? Was it these two because they both look a bit linear on the left hand side? I can justify all of them. I think that's all of the pairs, right? 3 choose 2. Yeah, that's all of the pairs. Oh, okay. So in chat, anonymous people. To be clear for Ruben, we are not testing people skills at interview. You don't need any people skills, and yeah, we're not restricted to the MAT syllabus at interview. We can do other stuff as well. But because we can explain things, and because we can give people help, because we can do follow-ups. So if hypothetically you are only good at completing the square, then you might get a really good math score. I don't just mean completing the square. You might get a really good math score, but perhaps not have done a realistic amount of preparation for maths at Oxford. That's pretty rare. But hey. In chat, 1 into 2, 1 into 3. No one's going for 1 and 3, but 1 into 3. 1 and 3 looks pretty popular. Why is that? Oh, I can't see why 1 into 2 works at all. What do you want to do? Do you want to sort of get rid of the B's? 1 into 2. So are people in chat? Let me get this, guys. So combining these together, maybe you want to eliminate B because it appears in both. But are you maybe going to tell me that this is true? Is that what we're going for? I'm trying to rearrange this B squared. Well, maybe you've done something like, you've done the other way around. So you've taken this expression for B, and maybe you're looking at A equals C minus 3 to the 2/3, which I suppose is kind of the same thing. I've messed up, haven't I? I have messed up. That is, yeah, A is B squared. B is A. No, I have messed up. B is A to the half 3 over A to the half 3. Eliminate B. There shouldn't be any B's at the end. So this is going to the same thing, but said differently. Plugging it in the other way. You kind of have a choice here about how you do the substitution. Is this what chat are up to? It's 1 into 2. Oh, you can get B to the 4 equals 2 using that. Okay, so I think people are actually going more for 1 and 3 as a more popular choice. Let's do that, 1 and 3. Let's try that, 1 and 3 together. What do they give? Oh, I see, so squaring A squared over here makes me think, well, I know A, and we can work out A squared. So I think that pair gives me C plus 5 is, and then A squared is B to the 4. That's not too bad. Okay. And then people, I think, want to use this equation to eliminate C as well. C is B cubed plus 3. So we end up with B cubed plus 8 is B to the 4, maybe? Do I like that? Not sure. Not sure. Maybe people are going the other direction. Which way are we going? Someone says, is the value B? I think it might be A, but we'll get there, won't we? 1 and 3. Then rearrange 2 or 3, making C the subject. Oh, I see. So I've followed it this way to eliminate C, but somebody else in chat wants me to make C the subject. How do I do that? So I've got to here. I've definitely got to here, haven't I? A squared is B to the 4. And then I could do something with like powers of 4/3 to compare this B cubed and this B to the 4, but I don't really want to. Now, how have they managed to get that involved? I would really do the difference here. B cubed plus 3 plus 5. So what have they done? I'm not stuck, but I am thinking about what chat is trying to do. Chat can help me out by telling me what they're trying to do quickly. If you select open application on your application, then yeah, a computer algorithm assigns you a college and you're treated exactly as if you selected that one from the drop-down menu. The option is there if you don't care. If you have no preference between the colleges, you can just put open application and we will assign you one. It's not an advantage, it's not a disadvantage, we just allocate you. And then you're treated exactly as if you picked it. I think someone did an FOI request at one point, which misled them into believing that it was a disadvantage. Because I think someone did an FOI request where they found out that people who'd made open applications were less likely to get offers. My explanation for that is that I could imagine the people who don't care about a college might also not be that invested in the idea of applying to Oxford and might have made weaker applications. But I think someone has sort of misled themselves by doing an FOI request without thinking about the kind of confounding factors underneath. I often feel this way about FOI requests, but there we go. Oh, solve for C, where are we going? Thank you, chat is helping. Log B of both sides, C plus 5. Oh my goodness, log B of both sides. Do I want to? Only a little bit, I think. Only a little bit. I don't want to bring logarithms back in. Sorry, Gavin. Go for it. Bring your logarithms back in. Large number of multiple choice questions. We won't be into that. About a large number of multiple choice questions. Won't be necessary and sufficient phrase questions. Awesome. So this chat person wants me to confirm that we won't use the words necessary and sufficient in the MAT when on screen this is basically a necessary and sufficient. I mean, I think I'm aware of the style of question which is on the Tamua where there's necessary and sufficient as words. Obviously, I can't promise not to use the words necessary and sufficient in a MAT question. This is just English words. It's like getting me to promise not to use the words if and then. Like, might happen. Okay. Combine two log-based Bs to get an equation that's a mess. Adam wants to know about different colleges. Big part of my job is to make sure that no matter which college you get allocated to or applied to, that your chances of getting into Oxford for maths are the same, no matter which one. So that you can be free to choose based on whatever else you like. That's a big part of my job when I'm not doing this. When I'm not stuck on logarithms. I think I am now stuck. Because I'm at a crossroads and I've got these different things. Your college can be linked with a college, but you are not required. You're not required to apply to that Oxford college, and it's not an advantage. The linking is all about information and guidance, and occasionally helping people with GCSEs or something, or showing them around Oxford on a visit. The link is not we have reserved places for people in Wales or something like that. Good. Okay. Where am I going? Here we go. What am I doing? So I think I've got an equation where I have b to the 4 minus b cubed equals 8. And I'm a little bit puzzled because in chat I think someone said that they just got b to the 4 equals 8. And I haven't got that. But that's okay. I have an equation here, and I think I can do some things, right? So this has got a repeated root at 0, repeated 3 times actually at 0, and it's got a root at 1. And then after that, it will go up. So what do I think? Different values of b. To get the value of 8 for a positive value of b, 8's up here somewhere. To get the value of 8 for a positive value of b on this axis, I think there's a unique value that does that. There's something complicated here where it goes down and then up again. But it goes back through 0 when b is 1, and then it goes up. So I think there's a unique value of b. And then what? Well, then once I've got a unique value of b, I know the value of c plus 5. And my unique value of b gives me a. I'm sort of leaning towards option A at the moment. It might be unique, but there might be only one value of b that does this. I can't tell you what it is because I can't solve this. I can't solve this. So my ambition has been reduced from solve to count the solutions. Which is easier than solving, so I'm happy. Quick question for chat. Has anybody else got this b to the 4 minus b cubed thing? Have you got this as well? Have you got some polynomial where you're wondering to yourself how many positive values of b are there that satisfy this equation? I think 1. I don't know what it is, but then that would give me a single value of a. Should I worry a little bit about c? Not really. So it's b cubed plus 3, which would be fine. Yeah, okay, so someone else has got that one. And going through here. I know someone who got in the 30s on the map but still got in. It's because of exceptional. It'd more likely be, I think, exceptional. Something happened on the day of the map. outside their control, which they declared. It's not impossible, never say never, but we have interviewed people with quite low maths scores sometimes. There's a histogram somewhere on each of the previous years. You dig through the past papers and the feedback for past papers, which is actually feedback on the whole admissions round each year. Your aim should not be 30 on the MAT. Your aim should be 100 on the MAT, but I say this for everyone. I say everyone should aim for 100 on the MAT, and I don't really know if that's a realistic aim for you or not, but I think it's an aspirational aim, isn't it? Okay. Adam's got the same. Good. Right. Okay. We've got down to this polynomial. I think for now, from there, I think it's arguing about a polynomial to yourself to say, come on. I reckon it goes down, it goes negative, and comes back up again. To get the shape there, I had to imagine that, well, for large values of b, positive or negative. I briefly imagined negative b for my sketch, even though it says positive in the question. I mean, I have to imagine the behaviour of the polynomial. But anyway, never mind. So that's up there. So I know it's going to come in. And then the question is, as it goes through here, does it come out the other side, or does it go positive? And I think because it's going to end up going like that, and it goes through the value of 1, I think it's got to look like this. It's a tricky question, actually, to sketch that curve. I could imagine using that in a bit of an interview. Not a whole interview question, but part of it could be, what do you think about when you sketch this? How do you know? If it was just in an exam or something, then you would just sketch it in the exam and then move on, whereas in an interview I can ask you questions about how do you know, like while you're doing it, I can find out what are you thinking, what are you doing. Good. You heard of MAT 2023 was hacked a bit late now, isn't it? MAT 23 had tech issues. I don't think it's a hacking incident. I think the tech was overloaded. Is that contradictory? I don't think that's contradictory. I think it's just a weird value of b over here somewhere. What are we saying? Oh, now I'm going to hover on this question a little bit. Hover on this question because SB thinks it's contradictory. I think I get about a value of b, and then I suppose I should formally go and check, like, for that value of b, I get a value of c, because then c is just b cubed. So get b, c is b cubed plus 3, that's okay, that's a unique value of c, and a is just b squared. These are all positive things because b is positive, so positive, positive, and uniquely divided. Like, once you've got a single value of b, there's only one way to square it, so I sort of think uniquely. Would a polynomial not intercept the y-axis at -8? I've got 8 on the right-hand side. I've got my polynomial on the left, and I have equals 8 on the right-hand side. If you like, you can subtract 8 from the whole thing and ask yourself the question of where's the root, whereas for me, I'm asking the question of where's it 8? That is up to you, I think. This pen is slightly too thick for me to label 8 on my axis up here. I like my polynomial, different colour. Polynomial pink for the left-hand side. That bit. Up to you. Yeah, different tech this year, anonymous person. Let's not worry about the 2023 one. Different provider. I mean, I did not hear that people hacked into the system, and I was in charge of MAT that year, so I really think I would have heard. I'm just amused partly that this rumour is the first time I've heard this rumour in, like, since ever, right? It was 2 years ago. Oh well, I guess that's the internet for you, but you can always start a rumour. Right, okay, what question should we do? Should we do another multiple choice question? Maybe not. Let's have a vote. Let's have a vote. I mean, that is a vote for multiple choice questions. So chat can let me know, but then maybe in chat you can tell me if you would rather do a long question. The long questions in 2013 look a bit like this. I heard that 2013 was all in French. No, don't start the rumours. It's not funny if I start the rumours, is it? I mean, it's basically not in French. People are voting, good. So long questions also look like this. I selected this one, I thought this would be fun. I don't know. It does a lot of this f of 1 minus t stuff and some identities and solving equations. And there's something going on under the hood here about solving simultaneous equations again, which I thought might be fun to think about. I don't know whether people in chat have had a go at this question, how they found it, if they want to talk about it. But let's see what they're voting for on the multiple choice front. Currently they're pretty much voting for J. Let's have a quick look at J. Yes, well, yeah, you would. Look at it. Yeah, okay, we'll do J. We'll do J. Yeah, okay. Why is C getting all the votes? Is C something funny like trapezium rule? Is it a joke vote? It's not a joke vote. Oh, it is quite hard though. Yeah, time out. Right, okay. Point taken. Let's talk about C. I think C might be too hard. I don't think it's a C anyway. So this is really weird because nobody does this, right? Nobody says the derivative of f is this. And when you have this, there's some, there's a sequence of operations here to do with differentiating and then plugging into x, which, I don't know, makes me very nervous. You can interpret the first two facts in terms of translations of graphs, but that's quite tricky. So, yeah, and in particular, it's the two out here. I suspect that this question is much easier if you know about the chain rule. So, I can't quite remember how the 2013 syllabus worked, but I think this is really, like, is it the chain rule or is it not the chain rule? Because what does f prime prime of 2x actually mean? You probably don't see anything like that until you've met the chain rule, at which point you're differentiating it with the chain rule. So I think f prime prime is the function that you get when you differentiate f twice, and that's not quite what we want here. So I think we want to differentiate twice and then put in and then evaluate the function at 2x. I think we want to differentiate it and then plug in 2x, and it's pretty tricky. I imagine all the others are going to be wrong options are going to be what happens if you do that in the wrong order. In particular, we know that f prime of x is g of x plus 1, but then the question is, what's f prime prime x? And that one I sort of think you do need the chain rule, because it's a function of a function, technically. But maybe you can think about it as, we don't know what this function g of x is, but we know that g of x plus 1, that's a translation 1 unit to the left. So we don't know what g of x is, but if we did, then we would have this function. This is f prime, this is the derivative f prime of x. So then the derivative, again, would be the derivative of this curve here, which, because the translation preserves the gradient when you translate, you move 1 unit to the left, and that translates the values over, and also the gradient at that point will now be the gradient 1 point to the left. So maybe that reveals that this is the gradient of g prime x plus 1. But then still, like, we still got to deal with the fact that, well, I know the gradient, I'm going to end up with something else. So I'm pretty sure the answer I'm going to get is C, but you know, I'm going to actually go and check, and I don't often do this, but I'm going to go and check what the solution said that. And if it is 4 out the front, I'm going to be quite upset. I'm preparing to be upset because this is just going to tell me that. This is just going to tell me, yeah, no, good, okay. Whoa. I only look at the solutions after you've tried, right? But this is going to tell me, yeah. So this is chain rule. Yeah. 2013, apparently they were trying to get away with the idea that you can just differentiate that and get g prime x plus 1 without, they haven't said anything about translations. They're going to have to think about translations. So then you do it again, and the plus 1s and minus 1s cancel out, and then at the end you plug in 2x. That would have been very hard for people to get the right answer, I think. This one here, it's a translation of h, so you end up with h of x, because it's translation in the opposite direction. So all these things are kind of, if you didn't have the translations, then you would just have the stack. You know, without the translations, you kind of have the stack. F prime is g, g prime is h, up to some translations. So then the second derivative of f is just h. But then for some reason they plugged in 2x. I don't think that's an excellent question. I did not write these questions because these questions are from 2013, which is before my time. I'm trying not to be too rude about the people who did my job before I started, but if any of you are watching, then that's the J rule. Was that on the syllabus? There's a request to do more work through videos. I think I said last week that I don't think I'm going to get them done in time because there's so much work. I'm currently producing a huge stack of other videos that I need to make. Maybe I should tell people. There might be like a warning video on this channel. There might be like a YouTube video that just says warning or I can explain. Well, that'd be good for clicks, wouldn't it? It's just like my face and I look concerned and the title is just I can explain. That would get clicks on this channel, I think. And then the explanation is just there's going to be a lot of videos uploaded here that are not about the MAT. We're going to upload about 20 videos that are about, they're for the first years. So the people sort of 1 year ahead of you who did MAT Livestream last year, I suspect that they're still subscribed to the channel. I'm going to give them lots of intro to university maths videos. So that's coming out next week. So don't panic if this channel is flooded with content you didn't ask for. Bonus. Yeah. So yeah, can you do a substitution, right? Can you get away with this by saying I don't like these? I'm going to say let new function be this, and then we have like it's weirdly got a capital letter in it, but we've got the fact that I want. And can you go let this function be h of x minus 1? Then we've got this fact that I want. You still need to think about the relationship between big G and little g to try and link these things together, and you've still got to pass all the x plus 1s through. And if you make a substitution, then you're using the chain rule, and not everyone here knows what the chain rule is. That's my part about 1C, I think. Intro to math is not supposed to be scary. It's supposed to be the opposite of scary. If it's scary, then I've done my job wrong. But it is like 1 year above. You'd be fine. You'd be fine, but you don't need to. TikToks. We're on TikTok. Maths department. We've been on TikTok for a little while now. We're growing a bit there. We're posting the same content on TikTok that we put on like YouTube Shorts or Instagram or Facebook. Different audiences, but at the moment, same content. But the maths department. Now, social media team is now next door to me. Now what I've moved. Social media team on the other side of that wall. They're on TikTok. When the intro to maths goes up, try watching the first video and tell me whether it's scary or not. Oh, I'm worried now. I've scared people. Nah, we'll be fine. Right, good. Okay, how's this going? D was a request, and the J was also keen. Let's have a quick look at this. D is a joke about the difference between squares. Not really a joke, sorry. I say joke not to mean funny, haha, but like when there's only kind of one small idea, and if you spot it, then you're good, which is difference of two squares over here. I think. Is that false? Have I just lied to you? Oh yeah, that doesn't quite get there, does it? That doesn't quite get there, because I've got all this mess on the right-hand side, so you get sad face. And then you remember that, hang on a second, 2y plus 1, I've seen that when I multiply out a different square. Can I rewrite this as, if I put those terms together with the y's, then I've got, hang on, I've got two squares that are equal. I suppose this is still a difference of two squares. But now I'm happy, because now I've got the difference of two squares. Okay, it's y plus 1, but now I'm happy, because I've got difference of two squares coming, I think. I can move this back on the left. So I had to move it on the right. I had to move that y squared on the right to kind of package it together into a little y squared plus 2y plus 1. But once I've got it over there. Yeah, so answer Ruben's question, which was... Oh, yeah, never mind. Okay. Hello, social media team. Sorry about all the noise through the wall. That is me recording MAT Livestream videos or doing things live. Any tips from Matt other than doing past papers? I think reflecting on your solutions. So I know that's not quite doing past papers, but like looking back on what you did. Like today, I'm trying to highlight that people have got choices. So over here, you could do difference of two squares straight away, or you could rearrange the terms for difference of two squares. And I didn't. I tried both. I had a little try something, doesn't work, back up, try something similar because it felt like it was close. I think you can look back on what you did and work out what was going on there. Now that you've seen your own answer, can you work out on the way back? Why was I so keen to do difference to two squares? Oh, because if it had been 0 on the right hand side, I'd be good, right? I'd have two brackets that multiply to 0. I need to make sure that when I'm doing difference to two squares, that I'm giving myself a chance to have two brackets equal to 0. So maybe I should always move everything onto the left. Always set myself up to have 0 on the right hand side. Maybe next time I'll try that. We'll see. There's an idea now. This is the thing I encourage people to do as well. Rosie's got ideas about symmetry. Yeah, that is a good idea. I like that. X only appears here, so there must be some sort of symmetry. I think all of these pictures do have symmetry, so annoying. Maybe you can start thinking about symmetry. Oh, you see, you've noticed better that there's not symmetry in Y. So actually 3 of them do have symmetry in Y and the other one doesn't. So maybe that, oh dear, okay. If you swap Y for minus Y, oh dear. Okay, good spot, Rosie. Yes, right, okay. Is it B? Is this one over here? Anyway, right, okay. You could plug in x equals 0. This question is susceptible to multiple different attacks. If you plug in x equals 0, then in this equation over here, you get 0 on the left-hand side. And you're having a very good day. Because, wow, look, y has to be exactly -1. Single value. Good. Any other attacks on this one? Angles of attack for this one? We'll look at J in a second. Oh, Rosie's saying question D. Yes, this is question 1D. I've read the chat message twice. I'm an idiot. Odd and even functions. Ooh, how does that work? So we're looking at, yeah, that's plus and minus signs again, isn't it? You look at what happens if you put in minus x. Do you get the same picture or a different picture? What happens if you put in minus y? Do you get the same picture or a different picture? I did not answer Ruben's question, which was because I worked out that it wasn't straight away. I saw your question was, is f prime prime just h? And the answer is yes. F prime prime is just h. I sort of started reading it, realised that it was from a while ago. My chat window refreshed. I try sometimes. I try. Okay, let's go. J. Am I going to turn chat off? Going to turn chat off just to make space for this one. They asked for J. They're getting a little bit of J. Here's the thing, right? There have been several past questions where this function gets defined. Maybe you've met it before, maybe not. It's sort of step-shaped, isn't it? So, in a different colour because I need a bit of axis, don't I? The largest integer less than or equal to x. So to start off with, that's 0. Integers include 0 and negative numbers. For more facts like this, see Introduction to University Maths. It's not a scary course. Okay, so this is like, in this question it seems to be called square bracket x. Square bracket. Oh! Sorry, I missed that one. When are the first year videos coming out? Maybe the weekend, maybe early next week, maybe late next week, maybe the week after. Oh my goodness. And they are videos, not streams. I have recorded about 8 hours of content, which took more than 8 hours before anybody asks. Anyway, okay, so 2 to the power of x, that's a different function inside these square brackets. So we'll need to think about whether that is greater than 0, greater than 1, greater than 2, and we're integrating all the way to n. So we'll get lots of different steps. Let's try and do a nice large picture over here. Okay, so 2 to the 0 is 1. Largest integer less than or equal to 1 is 1. I guess we'll start at 1. And then there'll be some step up, won't there? I might ask the question, where is the step up? But after a while, 2 to the x will be so large that this will be 2. I guess that happens when the value is 1. We will get the value 2. It sort of rounds down, doesn't it? It's the largest integer less than. Get 2, and then at some point we will, I think, get the value 3. And I'm quite interested in when, because the integral underneath is the area underneath, which I'm going to construct out of a series of rectangles. So I'm very interested in where this happens. Right, I have rectangles. So when is, I suppose the jump happens when 2 to the x is actually equal to 3. And after that, the values on the left get a little bit larger than 3, but we keep rounding them down to 3 until we get to 4. So I suppose it's not as big as 2, somewhere in between 1 and 2. And yeah, Rosie's got some steps. So then I think this is log base 2 of 3 or something. That's like the classic logarithm question, isn't it? There's definitely logarithms involved in this question because they're in most of the options. So I think that question mark there is log base 2 of 3. Okay, not too bad. Not too bad. We ask ourselves questions like, when does this thing start getting rounded down to 3? And then, and this is a bit horrible, we're going to have to keep going. We'll get lots of rectangles until we get to n, at which point this is just getting rounded down to, well, not really that bit of line afterwards, but just getting rounded down to 2 to the n, which is huge. So quite a lot of rectangles then. And then we're going to have to do some careful work to do this sum. How big do we think it is? Now normally when I've done this question on the stream before, I think, and normally I sort of now do the sum, but it is a bit tempting to say, how big do you think this is? We're adding up some rectangles. We stop at n over here and 2 to the n up here, so it's definitely not c, right? Because I'm going from 0 to n across, and I only just got to 2 to the n at the end. So that the entire board over here, the big rectangle containing everything, that's got size n, 2 to the n. That's way too big. It's a bit less than that, isn't it? I wonder if it's this much less. I wonder if it's that much less. Or is there something really tidy where, I can't really tell how large these things are. How large is it? Oh, there's a factorial in there. That's a bit confusing. There's a factorial in here as well. There's a factorial in here. So maybe I should try and guess how large that is. These are quite similar numbers, aren't they? These are quite similar. What's the difference there? The last one's got an extra 2 to the n multiplied inside, which I suppose log base 2, I could, take out that factor as well, bring out an n. Yeah, could you cheat, or not cheat, but could you make the question easier by trying n equals 1 to get rid of some options? Yeah, I think you probably could. So if you put in n equals 1, the answer should probably be, well, if I'm integrating 0 to 1, I just get this first rectangle. It should be 1. So that rules out c, doesn't it? Because c will be for number 2, being too large, too tall. And this thing will be log base 2 of 2 factorial. Oh, okay, that is 1. And this thing was log base 2 of 2 factorial. 2 take away 1. And this would be 2 to the n is 1, in fact. 0 factorial 1 log base, oh dear, log base 2 of 1, so it'll be 0. So I think our options are 0, 2 minus 1, 2, and 1. So I think we eliminate a at that point, and then maybe we have to think about n equals 2 to get some of these 3 rectangles and just see what happens. But there is some algebra that in each case the width of the rectangle is the difference between 2 logarithms, and there's some rather nice cancellation that causes this to simplify. Said differently, if you add up the missing bits of area up here, then they add together really nicely to give you, I think, all of that stuff marked question mark. Yeah, maybe this is an exercise for the viewers, but it does, what can I say? So it does, I don't want to do all the algebra in this gap here, but for example, from this middle rectangle, you get 2 times log base 2 of 3 minus, I don't know, something like this or something. There's 1 over here for the width of the rectangle. Sorry, that's the number 1. I don't know why I've written logarithms. I do know why I've written logarithms, but we're not there yet. And then for the next one, you get 3 lots of something else. I think in this case it's the number 2, isn't it? And this sort of keeps happening as you add on more numbers. The next one is going to have some width that involves minus 2. Oh, that's just off the bottom. Minus 2. And the next one is going to add some other number that we haven't worked out yet for this next one. But crucially, I want you to notice that this sort of almost cancels with that. It's 2 times that particular logarithm value. And here it's 3 times minus that. So you end up subtracting a lot of logarithm values. How many of them? Well, kind of 1 in every case. There's 3 times here and then 4 times here because the rectangles are getting taller. So you end up just subtracting lots of logarithm terms. And then you have to tidy it up a little bit, but it ends up being subtracting all of the logarithm terms, 1 for each value, which is why there's minus lots of logarithm terms here. I'm saying lots of logarithm terms because that's a product inside a logarithm, and you know some log rules to say that's a sum of lots of terms. You know, this log xy is log x plus log y. That fact. Meanwhile, in chat, Rosie has plugged in n equals 2, and that's ruled out all of the other options. Good job, chat. Right. Okay. Time for a long question, I think. We are going to vote. I showed one on screen, but there you go. We don't have to do that. Someone in chat, I don't know if this is this is being moderated slightly, but someone in chat just says, "Are you James?" I'm like, I have a name badge. I have a name badge. Welcome to the stream. My name's James. Good to see you. I've lost chat again. I keep losing chat. I go up here. Good. I can mark that as answered. What's the answer to this one? It's B on screen at the moment. There's some large contribution because at the end you end up with a very tall rectangle on the far side over here. Very tall rectangle, and there's lots of terms in the sum for the sum of all these areas. Lots of terms with minus signs on, so you end up with a combination that ends up being like B. Pretty sure. As well. If I don't apply to Oxford, can I still sit my MAT test? Sorry, no. If you're not applying to Oxford, then you can't take MAT in 2025. In previous years, the rules have been a bit different, but this year you need to be applying for Oxford to take the MAT admissions test. If you've registered for the test and you're not applying to Oxford, then I'm afraid your booking will be cancelled. Right, okay, currently 6 people have voted, and half of them, I don't know if it's the same half, have voted for each of questions 3, 5 and 6. So that's a nice little tie there. We will see. Right, right, okay. So this one in chat, Aaron says, they've got -1, minus, there's a lot of minus signs, but then plus, and that last term, let me think, that last term should be a little bit larger, I think, because that last term with the plus n log n plus 1, I think the final thing at the end here is going to be not n times, but 2 to the n times, because this final height at the top is really large. It's 2 to the n, not 7. That's the page number. And this final width is going to be n minus, and then this previous point, the rectangles get really narrow. This previous one is, I think, log base 2 of 2 to the n minus 1. So there's sort of this pattern here is, this is log base 2 of 2, this is log base 2 of 3, this is log base 2 of 4, and you keep going up the kind of chain of values, right, until you get to log base 2 of 2 to the n minus 1. So I think you get lots and lots of minus things, and then there's this final really tall, really large value, which is essentially because the last rectangle is really tall, 2 to the n times n. So that's kind of where that term has come from. Plus, I suppose I should have a 1 minus 0 or something. Yeah, that's fine, isn't it? And just put the first term in. Sorry if that was confusing anyone. I've missed out this first rectangle. That's our case check. Tidying up, there you go. Big sum for the value. We did do the algebra in the end. Lots of things cancel, more or less. If Oxford is my first option and I take the MAT, will my score be applicable to other universities? Other universities will not have access to your MAT score, and I'd be surprised if their admissions process was using MAT scores, because they've got no way to get the MAT scores. This is for MAT 2025. If you're watching this video in the past, then you've invented time travel. Well done. Maybe use that for something else. Lots of votes for 5 at the moment in chat. Good. Right, okay. Aaron says they've got this question, which is good. They also say it's been haunting them, which is bad, but now, good. Lots of votes for 5. Why are people voting for 5? Are people voting 5? Okay, we'll zoom in. Here it is. Here's 5. You're allowed to vote for whatever you like, of course, but this one I'm going to ask why. I'm going to stop voting. They voted for 5. Why do you want to talk about 5, chat? Acceptable responses could be just liked doing this question, or you didn't like doing this question, or you're stuck on part 6 of this question. want to be stuck on part 6 of this question, but you're stuck on a different part of this question? I don't know. What's the thought process here? And for Adam, knowing maths can never really hinder your application, right? But you shouldn't go into the interview expecting it to be a sort of A-level quiz for all of your A-level knowledge. Knowing things is always good, but make sure you understand the things that you've done as well, of course. Not saying you don't understand them, just prepping you that if you're hoping for a further maths quiz and you think it's an advantage because you've done further maths and you know that other people haven't, then I think you also know that that wouldn't be a good way of us running admissions, would it? I mean, it would benefit you if you've learned further maths and you're hoping for a further maths quiz, but somehow doesn't quite feel that. There we go. Right, people in chat, are they telling me why they picked this question? I'm not sure. They're asking questions about the question, so we're going to go for that. I feel bad for Adam now. I sort of feel like I answered that question quite rudely. Sorry, Adam. Good. I'm sort of pleased that they've done lots of maths content, but also trying not to guarantee them a place at Oxford. Balance of things, isn't it? Ivy just says stars and bars. They put a method for doing this question, which is also a method you could use for counting Skittles if you're interested in counting the number of different packets of sweets based on the combination of colours that are in the sweets, because it's been keeping you awake trying to work out how many possibilities there are for a bag of Skittles. And Anonymous asks about digit sums. The thing I know about digit sums is that they tell you whether a number is a multiple of 3 or not, or more accurately, that property, whether or not a number is a multiple of 3, is preserved by the operation of taking the digit sum. That's a slightly different way of saying it, right? If you add up the digits, for example, if you add up the digits of this number, the remainder when you divide by 3 is the same here as it is here, i.e. no remainder. They're both multiples of 3. People know that fact? It's about the remainder. It's not just a check for the divisibility. It's also a check for the remainder. 10 is one more than a multiple of 3. Things just work. Maths is good. Yeah, okay, fine. I've successfully got people to... Yeah, good. Artem, if you're applying for computer science, then you might like to look at the other questions. And in the long questions, there's often a kind of geometry question, which is often a bit of a pain because you have to look at a diagram. Computer scientists didn't do that question back when that was a thing, but the computer scientists did do multiple choice questions that involved geometry. So it's never been true that you get to avoid geometry by being a computer scientist. And in fact, this year everyone's doing the same questions as each other. So any geometry question, people will do. Yes. Okay. Let's see. What have we got? We've got applications of digit sums. Nobody's told me why they want to talk about this. They all voted for it. This is 2013 that we're looking at. Anyway, we've done a couple of short questions from 2013, 2 or 3, and we're having a look around this one. Oh well, let's just go for it, shall we? Maybe people just want to see me suffer by doing this. How many positive integers less than 100 have digit sum equal to 8? So these are 2-digit numbers, I suppose, or maybe 1-digit numbers. 1-digit numbers makes me think that they could be 8. That feels like quite a mathematician fact, doesn't it? 8 has digit sum equal to 8. You add up all of the digits of this number and you get 8. Okay, let's think about 2-digit numbers. I suppose they could be 80 or 71 or 62. I mean, there's an obvious way to list these, isn't there? I suppose if I keep going down, then I'll get to 26, 17, and then maybe I'd write down 0, 8, which I suppose is the same thing as the number 8. So I'll leave it. I decided to think about 1-digit numbers and then 2-digit numbers. I now realise that I could write 0 in to make it into a 2-digit number. Oh well. Okay. And then it asks about n, so we could maybe think about how to generalise this. They've told us that n is not as large as 10, so that's good. Yeah. Jacob voted for it because it looks fun. It is kind of fun, isn't it? And the question generalizes nicely from step to step, so I quite like that as well. I quite like the way it sort of gets harder as you go along. So then, to add up to n, we'd have, I think, all of these possibilities that the first digit could be. I'm going to change my mind. I'm going to include 0 for the first digit. Maybe you don't like that. Maybe you want to think about single digit numbers separately. That's a choice. I'm trying to highlight choices today. First digit 0 to n, and then second digit, whatever it needs to be. I should give it a name for the first digit, shouldn't I? And then second digit n minus that. Whatever it needs to be is what I've written there. There we go. That's probably not what I'd write in a test, but here we are. More interesting one is about 3-digit numbers, right? So less than 1,000 means 3-digit. It's 3-digit if I'm thinking about them having 0 on the front, like 007. Because now I've got some choices. Now I've got choices about what the first digit could be. Choices for the first digit. And then consequences. And I will need to think, if I'm going to do this, about what happens after I've chosen a first digit, which I might call A for my first digit. What happens next? What have I got left? I've got 2 digits left. I've just been thinking about 2 digits. The question builds really nicely. I've just been thinking about 2 digits. And I want them to add up to, oh gosh, n minus A. So then I've got lots of different cases, and I know what's going on in each of my cases, and I need to add all of those things together. So it ends up being something like triangle numbers, I think. Good. You'll have to tell me how to do this with stars and bars. So if you want to explain stars and bars in chat, then go for it. I think I can see what to do. But yeah, because there's a question there, n plus 1 is a good idea. Is there any benefit to doing questions the smart way? Yes, it's faster. If I get slower with a worse method, is it okay? Yeah, that's fine. Yes. Any method that works and follows the rules of the question, follows the instructions, and makes sense, ideally gives you the correct answer, that's all good. The advantage of doing things smartly and quickly is that you have more time to think about other things, plus you get to feel smart, which it's not the only reason I do things, but I do enjoy feeling like I've had a good idea. I don't know, maybe that's just me. So let's think about these consequences then, and maybe I'm going to do this one down in a gap underneath. Consequences. So if I put 0 as my first digit, if A equals 0, I think I'm now calling it first digit. I'm now calling that A to make it easier to write. If first digit A is 0, then we need the other 2 digits, maybe I'm going to call them B and C, other 2 digits, to sum to n. And I think there are n plus 1 ways to do that. Cool, I'm under chat, I'm turning chat off for a second, just for space. N plus 1 ways to do that by pi. If A is 1, then we need the other 2 digits to sum to n minus 1. And we know how many ways there are to do that. There are n ways to do that. The rule is you add 1 to the number, right? That's what we just decided. If you say digit sum n, I say n plus 1. If you say digit sum 3, I say 4. If you say digit sum k, I say k plus 1. If you say digit sum 7, I say 8. So if you say digit sum n minus 1, I say n. I'm just adding 1 every time as a rule. So there are other cases like a equals 2, a equals 3, where the cases will slowly decrease as you put more points into your first digit. You'll have fewer points left over until we get down to this kind of a equals n case, when we need the other 2 digits to sum to 0. And there are 1 way to do that. Welcome back to the MAT Livestream, where we say things like, there are 1 way to do that. We got caught out by the singular. Oh, I'm just off the bottom of the screen. There we go. Sorry. Good. Okay. I don't think I said anything about security arrangements. I'd really try not to say anything about security arrangements. People have maybe noticed that there are a few things that I don't comment on, and one of them is test security. Can chat work out why I don't comment on test security? Is the answer test security? You know, We'll get there. Okay, so I've got several different cases in which there are several different numbers of choices for what's going on afterwards for the second and third digits, and my plan is to add these together. Maybe there's different ways to do this. Maybe you just know what happens when you add up consecutive numbers. Maybe you remember the formula for an arithmetic progression, because that's what this is. 1, 2, 3, all the way to n plus 1 is an arithmetic progression. Maybe you know some sort of bars and stars thing for this, but I think it's n plus 1 times n plus 2 for 2. So I think my final answer is n plus 1, n plus 2 over 2. Cool. Yep, the number of ways for the second two digits decreases. Does the question make us do more digits after this? No, it stops. It does something slightly different. So n changes back to 8, and now there's an additional restriction. But we've now conquered so many things here that we've got like different choices of a is 5, 6, 7, 8, and I think I'll stop there at the cases, at the number of cases. We're now really good at making the right total. Between 500 and 999 just controls the first digits. I think I'll stop there, because I think if the first digit is 9, then I'm not getting any possibilities for the second and third digits. So I think I'll just check those. I'm not going to work it out on the screen, but you can check your answer on the MAT website. If you go back to the MAT Livestream page, we've re-uploaded the solutions document from 2013, so you can look at it over there. Okay. Kay wants to ask about whiteboards. Let's see if they've published what to expect on the test day. Has this happened? So it's 6 o'clock. I'm about to take a quick breather, I think. Let's have a quick look. So my colleagues in the Central University, because of all of the Oxford Blue across their website. Central University, there you go. We have some on our departmental website, but not quite as much. Have they got what to expect on test day? Yes, they do. I'm on the MAT page on Everything is Blue. I got here by doing ox.ac.uk/MAT, just to get to my colleague's central page. They've got things about ID requirements. They've got this. There is a Pearson View guys on what to expect on your day, which I think might be helpful if you're asking about what to expect on the day. Yes. Could I elaborate on part 2? Yes. I think I probably could. It's a fine-lined sort of pen. Someone in chat's asking. Put chat back on. I'm talking to chat again. Let's go. Didn't have chat off for very long at all there. There's a variety around the world of pens, I'm told, but the idea is that it's a thin sort of pen. Okay, right. Part 2. What did I do there? Oh yeah, so part 2. With digit sum equal to n, we don't know what n is, but well, if n is 8, then we already did this part. We had these different possibilities, where the thing we noticed was that you could sequence them like this, where it's a bit of an S shape, isn't it? Sorry for that. It's kind of weird shape to my handwriting here, but I've got the first digit going 8765432 going down, and I suppose it could go down to 0 if I include this as like 0, 8 on the front, and I could put it at the end of my list. How many possibilities is that? Well, 876543210 is 9 possibilities because of the 0 in there as well. The same thing happens for other values of n, provided n is not too large. The same thing happens for other values of n. The first digit could be n, n-1, n-2, all the way down to 0, and the other digit is just going to make up the difference to make this n in total. It could be 0, 1, 2, 3, 4, 5, 6, 7, 8, n on the other side. So that's n plus 1 possibilities. So really I'm thinking about this as possibilities and digits and choices, rather than thinking about them as numbers on the number line. Like the value of these numbers is not interesting to me at the moment. It's going to be interesting in part 6, where we're asked to add all of them together. Is that true? No, we're asked to add together their digit sums, which is much easier. Anyway, good, okay. Part 5, I think there's lots of different strategies, and you might always think about how you sequenced this and how you laid it out and how you explained it to yourself, that you'd got all of them. You have all of these different restrictions, right? So you have digit sum equal to 8, which we've just been dealing with, and one digit at least 5. So it's tempting to try and reuse your previous work, where the first digit was at least 5. Very tempting to reuse your previous work. Although be careful, because I think 611 is in there, And 611, if your plan is to just like shuffle the digits around to make other numbers, then 611 doesn't quite shuffle in the same way as 530 does, right? So previous part, you have numbers like 530, and maybe your plan is to now go 350, 305, 035, 053, 503 or something, to just shuffle these around. You've got different numbers. But careful, because you already had a couple of these. It's not just 6 times as many, right, from shuffling. 2 digits easier than 3. To add up the digit sums at the end is just sort of a totally different question, really, because well, it's just like combination locks, right? You have the different digits on your combination lock from 000 to 999, and you're trying to add up not the numbers from 000 to 009, but add up the digit sums. So the digit sum here is 0 and then 1, and after lots and lots of stuff, the digit sum here is 27. We're trying to sum these digit sums. But the key thing, I think, is that if you've got that like combination lock in your head, to realise that the different gears of the combination lock are just spinning round and round, and that what you'll get by adding up the digit sums is something a bit like adding up all of these digits. Adding up all of the digits that you see, and each gear on the combination lock has its own logic to how it repeats numbers and how fast it spins. So you can think maybe about what the units digit is doing. If you want to add all of these digits together, which, you know, to get the digit sum, you add the sum of these numbers in the row and then find the column total. I think I'm suggesting that we do the column totals first. And then add those. So the units digit goes through 0 to 9. How many times? 100 times. So we'll get something like this. I think 0 to 9 100 times. And the other ones do something similar. And then we'll add those. Good. Yes. There we go. Do you think I could get more into combinatorics of this? I think I could, because I think I know a little bit more about combinatorics. Lots of these puzzles are slightly wonky though, so having the extra restrictions makes things harder. And there is a strategy that is called stars and bars that some people know for combinatorics problems, for counting problems like this, where, let's see if we can do this. So the classic problem here is you have a certain quantity of objects. So maybe you've got 5 objects, and your task is to put them into a certain number of buckets, and you'd like to think about, oh, that one was not one. You'd like to think about the resultant number of things you've got in each bucket. So doing it like this gives you 2, 1, 2, and the number of ways to sort of split down those 5 objects into 3 buckets, getting some number in each, where I don't care which 2. Do I care which 2? No. I don't care which ones it is. I'm only interested in the number that I get in each. That's a big class of problems where you're kind of splitting something up. It's not quite the problem that you learn about when you're learning about choosing. If you've learned about choosing something, it's because, you know, I'm kind of choosing 2 of them, and then I've got some more choices to make. And oh god, it doesn't matter what order I did them in. There's an alternative way of counting these, just an idea that comes up a little bit, where you imagine that the objects are stored on a kind of conveyor belt. This comes up sometimes. I know it looks a bit weird, but here we go. You imagine the objects are stored on a conveyor belt, and the conveyor belt has 2 sorts of instruction. The instructions are this is like robotically controlled, and the instructions are either dispense an item. That's one thing that might happen. Or the other thing is move on. So you might have this thing where it, the instructions for this conveyor belt are like dispense an item, which plop, the conveyor belt rolls a little bit and an item falls into the bucket, and then maybe the next instruction is dispense another object, in which case plop, another one falls off the conveyor belt, but then maybe the next instruction for the robot is move on. So this whole robot apparatus moves to the right. Big box, there we go, come on. Why can't I select that as well? Because I've locked it. Because I meant to group it. 2 seconds. Move on. Put the points back on the conveyor belt. There we go. And the whole thing moves right. Good. And then maybe it dispenses an object and moves on. And this way of encoding what's going on using a kind of conveyor belt idea and the robot either dispensing objects or moving right makes this into, it moves and then dispenses a little more, makes this into a sequence of letters. This is a sequence with, well, exactly 5 of these and 2 move-ons. 2 move-ons. And that's a classic problem that you do know how to do, because each permutation of those letters gives you a different result for what you get in the boxes. Sort of how many times did you say D before you move on? Maybe 0. Each permutation of the M's and D's, and that gives you a way to do this quite complicated problem about putting things in buckets. Putting things in buckets by reimagining it as a series of instructions encoded by 2 letters. And then the classic permutation thing of how do you shuffle these around? There are 3, 4, 5, 6, 7 things on the screen. 2 of them are M, so 7 choose 2. Choose 2 of them to be M, and that gives you all the different ways to get a combination here. It's relevant for this question because you could imagine the digit sum. The digit sum could be a kind of if it's 8, then you can imagine that being 8 of these. And you can imagine having 2 digits being the kind of 2 buckets. So you need to put 8 of these blobs that are going to add up to 8. You can put some of that in the first digit or some of it in the second digit. So you've got 3 digits to play with, then you have 3 buckets. So the method is super powerful because it says, you've got 8 things and you need to distribute them between 3 buckets. The answer is just 10 choose 2. So it's super powerful, right? Because it converts that hard problem about distributing resources into this. But it cannot help you with the idea, unless you're clever and you do a remix of this version, it can't help you with the restriction, but the first digit has to be 5. Unless you go, well, okay, first do that bit separately, or first a different robot has already put 5 there and there are only 3 left. You can come up with ways to split this down. But I think that's the stars and bars thing. Right, good. We've just gone past 6 o'clock. So I guess I need to, I'm going to take a quick breather to look away from the screen for a minute and drink water. I also need to change this. Okay, good. If you've been staring at a screen for the last hour, remember to look away. Remember you are human. Humans occasionally blink. Humans occasionally drink water. Note that just because I'm blinking and drinking water, you can't assume I'm a human. That would be the converse. For more things about converse, please see Introduction to University Mathematics. Oh my goodness. Have I made too many videos? I think I've made too many videos. I think I'm going a bit silly. Tips for preparing for an interview? Yes, plenty. I have a bonus episode of this live stream in the future where I'll give some tips for interviews. Broadly speaking, for maths, it's maths questions that we want to do, not people skills. I want to do maths questions. If your people skills make you better at maths questions, then cool. We would like to do more maths. If you go into the past, though, we recorded a bonus episode about a bonus live stream about interviews last year, so you can go and find that one if you like. Although warning, I'm going to repeat content because I'd like to talk about the same interview questions. You can maybe find that on this YouTube channel that you are looking at now. K tried 3 by doing possibilities, 1s and 10s, and then set up for the hundreds. Yeah. What probability and stat stuff should I know for the MAT? We do counting things. We do this kind of binomial counting where you have like some M's and D's and you need to count Or 2 of these to be m, how many ways are there to choose 2 of them to be the m's? We do that sort of thing. We do a probability thing where maybe you flipped some coins and you think, wow, what's the probability that 2 of these coin flips are m on this coin that's labelled M and D? Like, I don't know what that is. But what's the probability that 2 M's and 5 D's of these 7 coin flips? Fair coin, 50-50 or something. Or even a biased coin, you can probably still work that out. For notes on that, you could see the revision worksheets that I made for earlier this year. This live stream had some notes on probability. You could have a look at those. Is it good that I'm reassured about that? I don't know. Maybe you're reassured about the blinking. It is medium. Necessary but not sufficient. There you go. Right, good. Okay, we're going to look at 2014 next. That is my plan. That is what we're doing here. Should we look at a short question? I think we'll do one short question on 2014. Do I need to speed up? Maybe a tiny bit. We've already seen some of them now because this is one of the years that I used for questions on the revision sheets, right? So I think we've seen this one before with its inequality and squares. Watch out for hidden quadratics. I think we've thought about these logarithms as well, and I'm always going on about things like this reflection question or this trigonometry thing. So I think we've used a lot of these in live stream questions already. Are people going to vote for J? Maybe not. Maybe we talked about J already. I circled it because I was expecting you to vote for it, but you're not voting for it, and that's fine. There's some integral. You want to integrate f. You should integrate both sides of this. You should give this a name, right? That's a for area. Oh, there it is. It's a for area. Integral f of x with respect to x. You get the same thing as if you integrate f of t with respect to t between the same limits. The x is sometimes called a dummy variable in this. That it's not a real variable because that's not really a function. It's just a number. It's just a. It doesn't depend on x. It doesn't depend on t. So you can use whichever letter of the alphabet you like. One of my lecturers tried to illustrate this point when I was at university by switching it for a little stick figure to say, this is the same value. This is also a. It doesn't matter. It's not a function of x or t or stick figure. It's whatever you like. It just goes there and there. You can't integrate it other way because you don't know f. People are now politely voting for j, so there we go. That's polite of them, isn't it? There we go. Thank you. I did want to talk about it. You get this area. None of us started using stick figures after we'd been, the truth had been revealed to us that we could have been using emoji for all of our dummy variables, and none of us went for that, which I sort of regret, but also it's probably good for the readability of my maths that I didn't immediately switch to emoji as a character set. Anyway, well, this letter appears in the question as well, doesn't it? So we have 6 plus f of x is 2f of minus x plus 3a x squared. And then our question is really, what on earth is f? What's the integral? I suppose I don't even really want to know f. I just need to know a. So actually this f in the equation is annoying to me. I want more things like a. How do I turn the f into an a? Well, I should integrate, shouldn't I? I should integrate from -1 to 1. And that'll turn it into an a. There will be consequences, everything else, but there'll also be an a on the left. And something else over here that I'm kind of interested in that might or might not be there. Yeah, no, I think it will survive. I can integrate x squared. Ooh, x squared underneath chat. I'll just have to pause chat for a second. Chat's still running. Just hiding an x squared, and it was an important one. Sorry about that. Yes, okay. Yeah, people inviting in chat as well. Good, okay. When we integrate, so I'm going to integrate everything, right? I'm going to integrate 6. You can't stop me. From -1 to 1, right? So this is like integrating constant 6 function. That's going to be 12 by the time I've integrated from 1 to -1. Or said differently, the integral of 6 is 6x, and then you plug in the limits 1 and -1, and you get 12. But areas, right? And I want to talk about areas because, well, I'm about to get this thing over here, which I'm sure someone in chat will tell me is what you get if you do integration by substitution, but not f of x, concentrate. I don't want to integrate by substitution. I want to tell you that that's the area of, you have f of x between -1 and 1, and you have f of minus x, where I'm going to draw that backwards. Does Miro let me reflect it? Can I draw a more interesting function as well? You've got f of x. That's only slightly more interesting. I don't know what I was doing. And on the right, can I just reflect it? Oh yeah, I can. There we go. No, it hasn't already worked. Can I put it sideways? No, it's not keen on that. Just wants me to scale it. Okay, I'm going to have to freehand it. And on the other side, you get this, but they've got the same area, right? When you integrate from -1 to 1, integrating that way or that way, you get the same area underneath. So this integral is also a. So when the dust settles, I have 12 plus a is 2a plus, I can probably do this integral, can't I? X cubed over 3, plug in 1 and -1, get 2 over 3. I think a might be 4. 3a is 12 or something. I like this question. It's just nice. I never have to solve for f. I reckon I can probably go back and solve for f now. And plug in 4 over here, and then, well, maybe I can, maybe I can't. I've got this fact about f and f of minus x I can't really deal with. How do I feel about this? Not good. I think there might be multiple functions f that do this. Not sure. Yeah, okay. I don't have to solve for f, and I don't think I'm going to. Other things going on. Could you do it with u sub? If so, could you show it, please? Sure. So, question in chat: could you work with this? If you know about integration by substitution, it's minus x inside. If you know about that, then you know that you get you have to change the limits. You know that you get this. You know that you have to think about the derivative in here, so you get minus du in here. But then you also know that that minus sign, you could use that to change the order of integration. So if you know that, and you know sort of 2 or 3 other things, one other thing really, that the minus sign, you can change the order of integration with a minus sign. So if you're good at substitutions, and you know about minus signs flipping the order of integration, then you can also get this, and that's a dummy variable, isn't it? I get -1 of x dx. Stick figure, it's a. Yeah, so this idea that doing a reflection gives you the same area. You can spell that out with algebra if you want to, but I think the intention here was for people to think about the area being the same under reflection, that being the transformation that's going on there. Not a lot of voting, but for D and I. Let's have a quick look at I. What have they voted for I? Oh, but this is nice, right? This is really nice. Right, let's have a quick look at it, but then I think it's long question time. Yeah, so how do you sequence your transformations here? You want to get from 2 to the x squared to that function above. I think it's clear that, well, this talk about stretching parallel to the y-axis makes me think about multiplying by, I don't know, 2 to the 3 maybe, because I know how multiplying by a different power of 2 works. And the thing about translations makes me think about shifting x in here. So I guess I could start thinking about translation parallels to the x-axis. What happens if I do that, followed by something else? Fine. I suppose I would get to the x minus a squared, followed by some stretch. So stretching it parallel to y, if I'm doing this one. Do I want that? Maybe I want that. Maybe I can make that work. Or maybe it's supposed to be the other one, where I do the stretch parallel to the y-axis, which means this thing, followed by a translation parallel to the y-axis. Oh, do I like that? That would do that, wouldn't it? I don't want that at all. I don't know, multiply by b and add c. No, I don't want that. That doesn't look right at all. And there's things about reflection. I don't know. Reflection in the y-axis would be fine. I guess I'll put a minus sign on x. Do I want that? Not really. It doesn't seem to do anything. I suppose if you did some translation first, then now you have like a slightly different translation. Is that good? Doesn't seem that good. We should complete the square, shouldn't we? Everyone in chat wants to complete the square. Yes. And somebody else says, I don't get how you said functions of 2 different variables give the same area. Well, I suppose the area itself isn't a function of any variables. So my point is, for that bit, my point was just that it doesn't really depend on which letter you use. If somebody asks you to integrate x squared with respect to x, That's the same thing as integrating t squared with respect to t. And the reason the same is you can just switch this x to t everywhere inside here. This thing is not really a function of x or a function of t. It's just the number 2/3. And 2/3 doesn't depend on x or t, right? It doesn't care. So maybe that's what's going on here. And the thing my lecturer would say is that you could go stick figure squared, d stick figure. I think they put brackets around the stick figure just out of like respect to try and keep it not too mind-bendy, but hey, anyway. Maybe it looks better if you don't put brackets around the stick figure. Anyway, here we are. And once you've completed the square, I think it really looks like some combination of translation and what is that, 2 to the minus 1? Like, once you've completed the square, I think you've really got this idea that something's been multiplied, and that's how you do a stretch parallel to the y-axis, and something's been translated parallel to the x-axis, at which point we're just thinking about what order those things have happened in. And I think I only really like b at this point, with 2 to the minus 1 and a equals 2, you know? Yeah, completing the square is pretty great. Yeah. So it's perfectly possible for functions of different, yeah, okay, good. I think it's b. Am I going to double check that? No, I think I'm not going to double check that. What do I think about the others? Parallel to the x-axis kind of gets me because don't love it. Put a factor in here. Different question. If there were a number outside the front of this x squared, it was slightly harder to complete the square exercise. Then I could imagine having some translation, having some scale parallel to x as well. That's kind of a hard question. Okay, if you did this question and it was fine, well, first, if you did this question and it was not fine, go back and try doing. I would like you to pick in each of these 5 parts. I would like you to pick some numbers for what the translation is or what the stretch is, and I would like you to check what you get when you do one followed by the other. And you probably won't get this because you won't pick the right numbers, but I would like you to practice doing those. If you found this question fine, I would like you to find a sequence of transformations that gives me this, and I should really concentrate to make sure this is possible, shouldn't I? Oh my goodness, how am I going to do this? Make sure it's positive minus b squared minus 4ac. Make this really large. Yeah, make this really large. B squared minus 4ac. I'm trying to make sure that there is a discrete. Why am I doing that? Maybe it's fine. Minus 4ac plus 4. Yeah, okay. How would you make this graph? Using, I think, maybe 2 sorts of stretch and a translation. Maybe you can do it in one of those, but who knows. Good. What do we do in 1j? We integrated both sides for 1j, which was an ambitious thing to do because one of the sides already had an integral in. Key fact, that's just a number inside the brackets there. It's actually the number we're looking for. We've got a name for it, so it's much nicer. At which point we can now integrate both sides and start arguing that things are just equal to a, until this all boils down to just being an equation that involves numbers and the letter a, because that's all that's really going on. Once you've integrated, you just get numbers for the areas involved, and you get a for the unknown area that might be involved. But the area is just a number, so we're just trying to solve for this particular number. Like, all the options in this question are just numbers. They're not functions of x. There's 4, 6, 11, at least 13 and a half, 23. So we're just trying to get the right number. So we're looking for an equation that involves that number. Crucially, and maybe this is my first step, is to give that a name, to realise that it's a number, and to give it a name. That's such a mathematician thing, isn't it? I realised it was a number, so I called it a letter. Letters and numbers. Okay, right. I think we're going to look at a long question, and I'm trying to accelerate just a tiny bit. We're going to vote for a long question. We're going to try and vote for one where, well, you can vote for whatever you like. What do I think people are going to pick? It's quite a hard computer science automaton question down here, which is kind of fun. If you liked that description of a machine that was made of conveyor belts and you wanted to give instructions to other machines, then hey, here's a whole framework for giving instructions to machines. We didn't make mathematicians do this question back in 2014, but you know, have a look. There's one of these truth or lie questions, and people voting for it. Let's find out. It's one with lots of numbers and possibilities. I think it takes a long time to read. Rhyming schemes is currently getting some votes. and it's one of these ones where you have a structure, so I want to talk about that, I think, a little bit. It's one of those ones where you really build up an equation and some boundary conditions. So this reminds me of a lot of applied mathematics, really. There's a region, I'll describe the region if we do this question, but there's a region where you know stuff about that's going on the outside, and you know something that kind of propagates information through the region, a bit like having a wave pool where you have a big body of water, you have a machine that's making waves at one end, and you know the waves are going to go through the water. You can follow the information through. That is the fluid dynamics person speaking. Anyone voting for 4? No, no one's voting for 4. Maybe 4's fine. 4 is a little bit, I don't know if we would do this with the new specification, because it's a bit double angle shaped, isn't it? Anyway, people are voting for 5 and 6 at the moment, but I'm going to zoom in on some questions and make comments and see if that changes. 3, I feel like we did some of 3 at one point. Maybe not. Maybe not. We have some properties of a function, including this interesting property f of x plus y is f of x, f of y. Interesting. Do I know a function that does this? Oh, no marks will be awarded for any use of the exponential function. Rats. Okay, bother. But no, I know about the derivative. Oh, okay. And then we're going to derive some facts. We're going to work out some facts, including a rather good fact about the number e at the end, but we don't know it's e because we're not allowed to use any facts about the exponential function, so who knows? Never mind. Maybe people are voting for this if they want to talk about the trapezium rule. I've realised why we haven't talked about this question. We haven't talked about this question because it's about the trapezium rule. It's a good question if you like the trapezium rule, but no one does. It's not on the syllabus anymore. If people have just joined, we used to have questions on the trapezium rule. We don't anymore because of A-level change in the UK. Not many people have voted for 2, which I feel like we might have talked about before. There's some polynomial fare over here, isn't it? People are voting for 5 and 6 at the moment, so we're getting ready to either talk about poems or to talk about, what's this, logic puzzles. I think I would rather talk about the poems in state space, and someone's just voted for computer science as well. They've not got a huge number of votes in a way because I suppose it's Friday. Exponential, yeah, e to the x is called the exponential function, and exponential functions are relevant for that question because, well, secretly the whole question is describing an exponential function, and the idea of that question is not that you spot it's an exponential and start talking about exponentials and things you know about exponentials. In fact, the question is worded so you don't do that. Maybe that's a good example of how a question might say, here's what you have to do. You're not allowed to use this advanced knowledge about exponentials, although for the MAT, the exponentials are not advanced knowledge. So never mind. MAT Live is on Friday this week because I had to attend a funeral yesterday, so I couldn't do normal Thursday service. So MAT Live is on Friday this week. Right, sorry, you saw the expression, you heard me say something like, ooh, do we know a function, and you said exponential. Sorry, got you. Right, people voted for the rhyme schemes. We're going to go for the rhyme schemes. Let's go. Some votes. Good. Okay. Let's see. Poets use rhyme schemes to describe which lines of a poem rhyme. I think that fact is actually true, by the way. I think they do that. Same letter given to 2 lines that rhyme. So the rhyme scheme A, B, A, B, C, D, E, D indicates that, oh my goodness, right, the first and third rhyme, they're both marked A. Oh my goodness, here we go. If a subsequent line rhymes with an earlier line, it's given the same letter. Otherwise, it's given the first unused letter. And for the purposes of this question, we're not going to run out of letters. Fine. Okay. How many different rhyme schemes are there? We are going to write Rn for this number. So there are 5 different rhyme schemes. So questions like this, and I've seen several, it's less of an obvious theme than the truth-lie questions that people ask about sometimes, but it is a bit of a theme. These kind of questions that involve recursion, where often the first part gets you to explicitly find some stuff, and then the next part describe a strategy for working out how many there are in general, and the last part might get you to count them as well. So we're going to see sort of just getting a feel for what's going on to start off with some notation for what they're called. we're asked to list all of these. I guess off I go then. So there's sort of A feels like the first one. Do we start with A? Yes. The first line of the poem is given the letter A, so I have to write out 5 things that start with A. And then I have to think of sort of 5 different structures for my poem. Ah, good. Welcome back to Poetry Livestream. So my poem could have 3 lines that rhyme. That's allowed. I suppose if I'm going in sequence, maybe I could go A, and then invent a new thing. Maybe I could have invented the new thing here, but then rhyme. And maybe I could do A, B, C. And I've got 4 so far, so I've missed a trick. There must be something I've missed. You know, I could do new. What have I missed? So sometimes you've got to go back and think systematically to think, I've got ones with 2 A's and a B. Could I have an A and 2 B's? I guess maybe I could. Maybe I could fill that in. Thank you, Kay, in chat, who has listed all of them. Actually in the same order as me. To have the A, B, B on the end. So when you think about the last line get previously, thank you, rhyme with one of the ones we already had. Okay, the idea of doing this first part, behind the curtain I suppose, the idea of doing this first part is that we've got some experience now of thinking about the possibilities, and then the recurrence down here just off the bottom of the screen, we're going to get to eventually a recurrence relation. I'm going to zoom right in on it. There we go. This is called a recurrence relation. It relates values of some function we haven't met C yet, but relates values of that function to previous values in some sense with smaller numbers there. Sometimes these functions are written like f of n k, and sometimes they're subscripts to indicate that there's some sequence of numbers indicated by the 2 sorts of subscript, which is quite a complicated sequence, but here we are. Right, let's zoom back out and see what's going on. Right, CNK denote the number of rhyme schemes for poems with lines with n lines, maybe with lines n, that use exactly k different letters. Is that just a typo? Just a straight up typo? Possibly I've introduced that. That use exactly k different letters. For example, C through 2. Behind the curtain again. The idea for a recursion relation like this is usually that you've had some idea about how to relate the things together. Why is C and K anything to do with shorter poems or poems with fewer letters or both? And the question usually gives you that idea or strongly hints at how you might split this down. So this question says, use exactly K different letters. This is a way to split down the problem so that I have over here some that use 1 letter or 2 letters or even 3 letters, and those are different. And it's not how I split down my cases before, but maybe it's how I split up my cases now. 3-2 corresponds to the rhyming schemes. Oh, this is good, isn't it? It's on the screen. I couldn't think of it. It was on the screen. That's my last missing one. I should have kept reading. Lesson for self. Keep reading. So what is CN1? Tells you how to do this. Is there an email for New College? Yeah. There's an admissions. If you go on the New College website and you try and find admissions, if you want to talk to the admissions office, if you want to just talk to, I don't know, New College itself, it's a building, but you know, the admissions office, I assume they've got an email contact. I'm pretty sure it's something like admissions@new.oxford.uk, but maybe Google that before typing it into your email if you want to talk to them. Good. Okay, it gives you marks early on as well, this first bit. You know, you get some marks for trying. So CN1, you see they're still trying to give us marks for just understanding certain cases. So CN1 is talking about 1 different letter. So that is going to be a poem of n lines that is A. Nice. And then CNN is the more experimental poetry where I have to use n different letters. So I have to use a different letter every time. So I think this is 1. There's only 1 poem rhyme scheme like that. And there's only 1 rhyme scheme like this where you use lots of different letters. But somehow, it's interesting, it's equally restrictive to have to rhyme as to have to not rhyme. There's only 1 rhyme scheme in either case, if you have to do something every time. Good, right. Explain your answers. We're going to get some marks here for explaining why. So words. It's probably a good idea here. Okay, here's the interesting bit for me though, which is we're asked to explain why, and look, by considering the final letter. So this is also a way of breaking things down. So when we think about that final letter, that's the last line of our poem. And we're asked why. Overall, we've got n lines and we've used k different letters. What's that got to do with, over here on the right, I can see C n-1k, which means a shorter poem with k letters, shorter by one line. Shorter poem, k letters. That's what this is counting. I think it's C for count, maybe, in my head anyway. And this is a shorter poem with k-1 letters, which I suppose I'm going to say fewer letters. And then I suppose in order to get to k letters, we need a new letter. Notice how even though I said words up here, because you've got to use words to explain, here I'm trying to interpret things with words just to get to grips with them. I've become more aware over the years that I need to do this, that I don't function purely with algebra and equations. I don't understand things by mashing equations together. I understand things by working out what they mean on a kind of human understanding level, and then I get insight about what algebra to do. Here we're just justifying something, we're explaining why, so maybe I will label this words again. So maybe chat can tell me. Yeah, it's interesting, isn't it? Maybe chat can tell me that what's the link? We've been told to think about the last line of our poem, and maybe different cases, and there's some link to shorter poems that either have k letters or slightly fewer letters, only slightly, because it's not just randomly fewer, it's k-1 fewer. What are those two cases? And why is this one multiplied by k? Why is that one being multiplied? And the other one hasn't. Several things to explain, right? We're going to get so many marks for explaining, because there's so many things to explain. And then the rest of the question is fine, because the rest of the question is going to get us to add things together and do some calculations. But we've now got loads of information, and I will draw you that region in a second. I think n1 should be n. There's only one letter to be used, and somebody else says, why isn't it 3 factorial equals 6? And both of you have missed the bit of the question which says the first line is given the letter A. The letters are not created equal. The first line of a poem's rhyme scheme is always A. So the question is not how many ways are there to shuffle around A, B and C. The letters are not created equal. The first letter has to be A. And there's also a rule about you have to use B before C. If a subsequent line is given the same letter, otherwise it's given the first unused letter. So there are these additional rules. In some sense, why isn't it 3 cubed? Right? There are three letters each, and there could be. Why isn't it 27? Why is it just 5? And it's because there's extra rules about how the letters work. There is quite a bit. 2 paragraphs, sort of 3. 2 paragraphs of readings to it at the top of this. Anyway, good. Okay. Bye, Anonymous. Take care. Yeah. Sort of. It's smaller than 6, but it's also smaller than 27. And I sort of think 27 is the wrong answer. I guess 27 is more wrong than 6, but 6 is kind of wrong in a different way, because most of mine are nothing like permutations of ABC, and kind of further away. Anyway, never mind. So is chat explaining? I'm not sure chat's explaining. I'll leave him to it. I think this is because the last line of our poem might rhyme, or it might not. And if not, then it's a new letter. It's the k letter. And everything else must be using k-1 letters, so that this last line can be a surprise. That's what this last bit means. Plus, there's this case where your last letter was a new letter, and you had k-1 letters in your previous n-1 lines. We know how to count that. Well, we know a name for how to count that. We don't know the value, but we know it's C n-1 k-1. That's if your last line is surprisingly not a rhyme. Don't know how I feel about those poems where the last line surprisingly doesn't rhyme, but I'm sure they exist. Or it might rhyme. If it rhymes, it's got to rhyme with something. And you might think that the choice there is which line should it rhyme with. There are n-1 previous lines, but of course they might not all be different. And the beauty of this method, thinking about how many letters you've used, is that we know how many possibilities there are. That if your final line rhymes, it's not a new letter, it's one you already had. How many did you already have? You had K. Because this is not a new letter, and you have K letters overall. If we're talking about C and K, you have K letters overall. So it's very tempting to say there are n-1 lines, so this last thing could be n-1 things, but in fact, if you're using K letters, that restricts it. Good. Isn't the first part counting all combinations of length n-1 and the minus K accounts for the possible cases of the last line? Yeah, I guess sort of. Yeah, first part counts all combinations of length n-1 with K letters. So you've got to kind of, your explanation has got to kind of cover the comma K here to say with K letters, and it's got to say kind of cover why this one's K-1, and it's to do with whether that last line rhymes or not, whether it reuses a letter or whether it uses a new letter. Anyway, I think this question is really interesting. We then go on to do the calculation, and we can do that calculation because if you have in mind there's two letters here, N and K. If you have N and K as kind of on your axes, it's a bit of a weird plot, isn't it? Then we have lots of things we can work out. So C11 is just the poem A, so we know that one is just 1. And then as lines or something, we know Cn1, we know these values. They lie for different values of n, K is 1, they lie over here. I'm trying to label these points like 1, 2, 3, 4, 5, 6 on my n axis when K is 1. And then further up, we also know that if K is equal to n, and that's on this line, these points here, going up this diagonal line, going up this line, we know the values of Cnn over here. Cnn is 1. And over here, along this line, we know that Cn1 is 1. Missed a comma. And then the question is, we need to try and work out the values in this region. So we've got a kind of big triangular region. We know what's going on the edges, and we want to work out the values in between. For example, what's C3C? And this rule is lovely because this rule relates together wherever you are in the picture. It tells you Cnk in terms of things in n-1 in the previous column with either the same value of k or 1 less. So there's some rule about combining numbers together, like in binomial coefficients, like in Pascal's triangle or Yankees triangle. You can combine together these numbers to get the new one. So you can build each row of this triangle by looking to the left at previous rows of the triangle. If you turn your head sideways, they're rows. I guess I should have said columns. You can build each column of this triangle by looking at the previous column of the triangle. So I like doing this chart because it's got it's two-dimensional, right? It's got n and k, so it's 2D in my head. You might prefer to do that as like a table. People would definitely prefer a table, wouldn't they? I can see it now. N and k. And maybe I'll put n down this way. So n for the number of lines, which could be 1, 2, 3, and then k could be like the number of letters you use, 1, 2, 3, and then same thing, right? But you have like which way around is it? So when n is 1, you know it's 1's over here, and when n is equal to k, you have these ones don't exist. So these ones don't exist because you're asking to use too many. No, these ones do exist. I've confused myself. Some of them don't exist because you don't have enough lines. I've really confused myself now. Yeah, Cn, 1. So it's when k is 1. These ones are 1. Table. There we go. Got there in the end. These ones don't exist because k is too large. I'm trying to use too many letters, and I don't have enough lines in my poem for that many not rhyming things. So I think maybe you're happier to think of this as like a table that you're filling in. where each thing is reading n-1, k, and 1 feeding in. And then it is rows of this triangle. You've got two big rows of 1s and you're filling in things in between, but you have a slightly different rule because of this k. So it turns out to not quite be Pascal's triangle. Cool, right, I like it when there's a kind of way to visualize things. I don't know if I believe in the learning styles thing, but I like drawing pictures. Last two parts of this question. Well, part 4 asks you about Rn again, and that's normal for questions like this, where there's been some idea that wasn't really our idea, it was the question's idea, to think about the final letter and think about the cases. But they walked us through it, and we had to explain what was going on, so we had to follow something complicated. There's often a part to link that back together again to say, well, what did that tell you about Rn, right? How did that tell you about Rn? Which here is trying to combine these things back together again. So, for example, R3 is 5, sort of 1 plus 2 plus 2 or something. It's in separate cases. 1 plus 3 plus 1, I suppose. Is that true? R3 is 5, and I think it is for R3. That's the number of rhyme schemes with that many lines. So we need to add up the things in a row. Haven't worked out that number yet. I think it might be 3. So quick check. You're supposed to go. So n-1k. You're supposed to have 2 of those and 1 of those. So it is 3. And also I can see 3 things up there that use 2 letters. I missed one of them, but I found it in the end. So that's 3 over there. Okay, so we want to add those things together. Brilliant. And then we're going to work out R4 by using our rule to add these things together. Can I use the rule? I'm not sure. I might leave it as an exercise. 2 times the thing with the same value of k. I want 1 of those. So 6 and 1 is 7. I want 3 of those, and 1 of those is 6. So I think if I add all of those, I would get 15, but I might go and check that. I might go and try and list them. And this also gives us a systematic way to list them, by the way. So I could list them and then check if I'm missing any by thinking really hard. That's not really how you do this, but hey. And then finally, we're asked for N2, which is a little sort of bonus bit of question. We could use this relationship that we've got, or we could just start again and think about N2. So this is poems with n lines and 2 letters, just A's and B's. It has to have a B. I suppose I can imagine lots of combinations of A's and B's. Is it as many as 2 to the n? Maybe not quite that many, because the first letter has to be A, and I suppose I'm not allowed to have just A's. So you could either go and think about this from first principles, to go back to what does that mean? What is C? What does n, 2 mean? Or sometimes you can reuse the previous parts. We haven't solved this in general, but maybe we could start looking at this sequence 1, 3, 7 and say, well, what's going on there? What happens? It's twice that plus 1 of those is 15, and then after a while maybe you get an idea about twice that and 1 of those, so you get 31. And once I've seen 1, 3, 7, 15, 31, I've got a strong feeling about what's next, right? Is it 63 next? So twice that is 62 and 1 of those is 63, yeah. So I've got a strong feeling about what that sequence is. Or we could go and think about sequences with A's and B's then. This one's bad because it's only got 1 letter, or something like this, right? Like, how many possibilities are there for A's and B's? And here you've got 2 possible things that you're rhyming with. You've got to introduce A's and B's at some point. So there's usually a couple of routes, either building on your understanding from what you had before, or going back to basics. I can't tell you which you should use because I've seen both. I've seen past questions where the correct thing to do is to sort of plough on with whatever horrible relation you had before from the previous part, and I've seen ones where it's like, oh, actually, back to first principles. I think I can do this one either way, just about. Something to do with powers of 2. I think it's 2 to the n minus 1 minus 1. Like ban the thing that's just A's, but I'm not sure. I want to go and check it. Maybe my justification is going to be a little bit of this argument and a little bit of checking it in the equation. It's nice to have 2 ways to do something, isn't it? Because then you can check your own answer. Right, how are we doing? It's just about coming up to 7 o'clock. So I think I'm thinking about wrapping up. I liked that. We haven't talked about 2015. Sorry. I guess I owe you 2015. I don't know how I'm going to fix that. Just realised I haven't talked about 2015 at all. Whoops. What do you want, chat? 2015? Just a little bit? 5 minutes? I think this question has a pretty similar... No, it doesn't. This question is completely different. It's a bit of a mess, isn't it? Look at all that. We made everybody do this back in 2015. Everyone go and calculate this. You're supposed to work it out a little bit at a time. Yes, please, for just a bit of 2015. Okay. 2015. This question is trying to scare you by being very, very complicated like this. You're supposed to work it out piece by piece, just a little bit. For example, you read all of this f as well, function of 2 inputs, but then it just tells you to work out f of 5, 2. And then we're asked to think about a simple formula later on. Explain why this formula holds. We've got p, which adds 1, m, which subtracts 1, and s, which does some sort of switching behavior depending on whether y is positive or negative. So I think there is something simple going on. In particular, once we've done f of 5, 2, we might do f of 5, 3 to see what's going on for different positive values of b. And oh, it's recursive, isn't it? It's got f inside here. So in order to work out f of 5, 2, maybe we have to work out f of 5, 1. I'm saying 1 because m subtracts 1. So we have to work out f of 5, 1 first. How are we going to work out f of 5, 1? I don't know. Are we going to work out f of 5, 0? I don't know. I suppose we'll look over here and say, hang on a second. This s function, if I'm looking at different values of b, eventually this part doesn't matter. Yeah, okay, so I'm going to have to go right into what s means as well. Because s means that the behavior of the s thing means eventually, look, if x is negative, then it doesn't depend on z anymore. It just spits out the value of y. So s of minus 1 y, stick figure or whatever, is just y. Because x is negative in this example. It doesn't matter what that is. So this could be like the most scary combination of p's and m's and stuff that you've ever seen. But if this b is less than or equal to 0, then it doesn't matter. I think that's my way in. I'm going to maybe work at f5, 2. I'm going to quickly realise that this needs f of 5, 1. I'm going to think about 5, 1. I'm going to realise that that needs f of 5, 0. I'm going to think about 5, 0. I'm going to realise this is going to go on forever. Then I realise, oh no, the switching, when you get down to b equals 0, the switching means that I don't care about this anymore. So actually the loop stops there. And I just get p of a, which I guess is a plus 1. Okay. So f of 5, 0, or anything 0, I suppose, is just a plus 1. Is it? What's a? F of a 0? Yeah, good, okay. So building this up from smaller cases. What does it say in chat? You could think of this as a for loop. I don't know. Computer scientists are probably going to think about this in terms of for loops, aren't they? I've got a feeling this question may have come out of the computer science department. You can sometimes see by its sort of switchy nature of what's going on. Is it running down a counter or something and then checking when the counter gets down to 0? I don't know. I feel like a computer scientist may have been involved at some point of writing this question. What do we do? What if we just do f5, 1 and use that to do f5, 0? Is recursive, but is that valid? Well, I would like a value at the end. So if yours is in terms of f5, 1, what do you say? I see, so you would go something like f5, 2, and then you know the switch thing, c is a positive number, so it returns this thing, p of f of a of, oh, I know a, I see, which is, if you know what p does, it adds 1, you know it's f of 5, 1 plus 1. I'm not sure that's going to get you marks for the value. I mean, it's a true fact that it's f of 5, 1 plus 1, but surely you want to know what f of 5, 1 is, right? Surely you want to do the same thing, but with f5, 1, which looks at the switching thing, and 1 is a positive number, so it returns f of 5, 0 plus 1. And surely now you're either worried that this is going to keep adding 1s forever, and actually the value will not stop being loads of plus 1s, or you're thinking maybe it's time to just check what's going on for 5, 0. So the switch thing here sees 0 and returns 5 plus 1 instead, this PA thing instead, which is 6. So then we have 7 over here, and we have 8 over here. The value is 8, right? And I guess I sort of see what you mean, that if you just write down f of 5, 1 plus 1, you've kind of written down a true fact about the value. But if the answer is 8, then it's kind of hard to give people marks for things involving loads of f's and 5s. So it's like, yeah. I think we have fewer people this week because it moved to a Friday, but I think it was quite nice. And we answered some questions. I think that helped some people. Count specific combinations. Always for counting specific combinations, I'm going to go and have dinner too in a minute. But for counting specific combinations, it always working systematically. So having some sequence. If in doubt, I go alphabetical or listing things smallest number to largest number, just to have them in an order, so that I know I haven't missed any. And your other question there was about proving formulae, which is often about explaining why something's true. Like the one we were just talking about was all about why the number of possibilities was like that. So all of that is in the description of what choices you're making along the way. My theme for today has been the choices that you make along the way, which is both something you might think about for problem solving and something that you might count for a combinatorics kind of counting question. We had a few notes about counting on one of the revision worksheets. I think it might have been, not the first one, but maybe the second one. Chat's going to tell me it was the first one, but we'll see. I do normally stop at 5. Yeah, thanks. Good. There were some notes. Let's see if I can find them. I'm going to dive in and see what do we say about counting back in there. Oh, it's algebra. It was number sheet 2. Yeah, sheet 2. So on the revision, there we go. MAT Livestream. Lovely gradient. Oh, wow, pinks and purples. Fantastic. Algebra. In the algebra worksheet. So this was a live stream. When was this? Back in June. Sort of moving some heavy machinery just near the office. I assume it's the social media team. Have you seen the saxophone video that we put out recently? That's very good. That was not the saxophone. That's not Josh. Don't worry. What does this say? So this has got some notes on combinations. This is somebody else earlier asked about kind of proof and combinations probabilities, but I think the thing they asked about for MAT, which is that formula there. I hope they find it. Good. I hope functions in Oxford are more fun. Yeah, I've got some stuff on functions in Introduction to University Mathematics. Not in a very helpful way for MAT. And if you're thinking about watching my lecture videos for hints on the MAT, then I think you'll be a bit disappointed and you'll be 8 hours in. There aren't hints for MAT buried in other content. I just have to make a lot of content, and I'm not using it to try and drive YouTube or something. Right, I'm just excited about it, which is why I keep mentioning it. Good, right, okay. This is just a gaming keyboard. This is a gaming keyboard. It doesn't have any LEDs on it. It does have quite large buttons. Right, I sort of get paid. This is sort of my job. It's sort of part of my job. Poetry question. Yeah, okay. What else have we got? I saw these are correct values around here, but what is this part doing at the end here? In this question, right? Explain why your function gives the correct value. Well, like we're trying. It's asking you to build a different thing that just add A and B together, which is kind of fun. Oh, that works when negative numbers B, so it's going to need to like add to B recursively and then stop. It's a different sort of recursion, isn't it, where it refers back to F, but you kind of build up from there. Would I do this with the table? Maybe I'll do this with the table. A's and B's, right? You know, A, B. Oh, how do we do these tables? A's and B's. So then you get, and somehow the value here relates to the value with a lower value. I think when B is 0, we know what's going on. We're happy about all of these. And we have some rule to say that this relates to A and then B is slightly smaller. So given this value, we can work out this one. And I think it just adds 1. So I think you have some little value over here that you're happy about. It's just adding 1 as you go to the right. And then the other part of the question is kind of do the other thing. No one ever does this, to draw a table this way around for negative numbers. No one ever does this, right? But you know, you get happy face over here to say what's going on for 0, and then try and get something which gives you the values going the other way. Do you just swap all the M's and P's? I don't know. maybe not. Any questions that could benefit from knowledge of binary trees? I'm going to say no, and then you're going to find one, aren't you, where your knowledge of binary trees was really helpful. There's a question that uses binary numbers, and there's a question about trees off the top of my head. I don't know if there's a question about binary trees. Not sure we've done one. Maybe that's a good idea for the future. Counting. Oh, counting, all right, different sorts of counting. Yeah, I mean, it's just hard, isn't it, right? The sort of counting. So over here, this sort of counting. The game is usually that there's some additional rules. That the game is usually not, as you've spotted, usually not, this thing is just n choose k. The rule is usually add some extra restrictions, and then we usually have to do some exploration at the start. Like probably these new rules, I don't know about rhyme schemes, I don't understand the rules as soon as I read them. I've got to explore them, and it took me a while to find that there were 5, even though I was told there were 5, right? So this is hard. And part of this is modelling kind of university thing where you have, I mean, maybe the ideal skill for mathematicians later on in life is you read this bit, and then you somehow have the idea to look at the final letter and to build the recurrence relation and to find some values. And that's not how this MAT question works. The MAT question has a lot of help. If this was an interview question, it would have a lot of help. But the thing we're trying to train mathematicians to do, I suppose, is to read a setup like that. Here's a problem. How many are there? And to come up with the idea of splitting the problem down, to try some small cases, to work out which cases are easy, and then work out how hard cases are related back to easier cases. And if you can do all of that, then you can solve really quite hard problems by splitting them down into easier problems and solving those recursively if you have to. The addition there of recursion and the idea that you might use a computer to refer back to previous cases and build up your cases systematically is why a lot of this maths computer science stuff is so powerful. But we have techniques for splitting down big complicated problems into smaller problems. Right, binary trees are trees where every object has 2 underneath it, so they're double in every row. They come up a lot in computer science. They don't come up very much in math. I'm really struggling to think of a math question that's got anything to do with binary trees. Seemed cool though. Right, good. I'm going to call it there, I think. Thanks for joining in. Sorry we didn't do really any 2015. If I remember, I will have it around in the Miro board somewhere next week. So if you're watching this and you're irritated that you've got to the end of the video and I didn't talk about 2015 at all, well, good news, we talked about quite a few of these questions on various bits of MAT Livestream already. I don't think I've skipped anything important. Okay, what's this graph? What's going on here? Wow, it's in radians, but what is this? It's not the right answer, but what is that? Can you work out what that is? You know, I'm not saying that's important, just fun. If you wanted to see something from this, you could let me know at the start of the next live stream. Or I suppose in between you could put a YouTube comment saying, I can't believe you didn't do 2015. Question 4. That's a good reason I haven't done 2015 question 4. That's really hard. Right, okay. Good. Bye, Mary Ann, Anonymous, and Kay. I think I'll leave the dinner question. Right, okay. I will see you in, I need to subtract 24 this time, don't I? So it's not 166, it's 142. I'll see you 142 hours for another episode of the Oxford MAT Livestream. Until then, have a good evening, have a good weekend, and have a good week. See you soon.